Hey folks, Kevin here. Well, it's March 26, 2019, and today's topic is arc fault circuit interrupters. So, as many of you are aware, I've been working out in a workshop. Recently in the northern workshop, we've installed sub-panels in the northern workshop and the south workshop. I've super insulated the partition between the two shops and super insulated the interior surface of the northern workshop and put up all the studs, and we're in the process of installing plywood for the internal surfaces of the workshop at this point. I've also last week posted a video about installing the 20 amp electrical outlets all around the perimeter of the shop as well. And one of the things I'll be doing next is hooking up all those outlets as well as other outlets and wire and lighting structures as well. And I've described before that I've created an access panel all the way around all the walls where the wiring is going, so that I can easily get to the wiring and get to the outlets as well. And an upcoming video is going to be when we install the circuit breakers that hook all of those wires feeding all of those electrical outlets so we're up and running. And today's topic is about the arc fault circuit interrupters, and it has a little bit to do with the ground fault circuit interrupters as well. So I think I'll start off by giving you a few facts and statistics. So home electric fires account for estimated 51,000 fires each year, 500 deaths and more than 400 injuries, and 1.3 billion in property damage. Each year in the United States, arcing faults are responsible for starting more than 28,000 home fires, killing and injuring hundreds of people and causing over $700 million in property damage. Now again, our ethics here are self-care, earth care, people care, and future care. Certainly with ground fault circuit interrupters, we're all familiar that in the presence of water in the kitchen, in the bathroom, in the laundry room, outside where electric outlets are, in all of these, and in the garage, code requires ground fault circuit interrupters because it helps to prevent us from getting electrocuted. So that's very important for self-care, but also important for self-care and people care, earth care, and future care is the loss of property and people to fires as well. So that's where we talk about arc fault circuit interrupters. First thing I'm going to talk about though is, first thing I'm going to say is a disclosure. I'm not an electrician, I'm not an engineer. I'm a retired veterinarian who's a do-it-yourselfer and advocate for learning as many skills as possible, but empowering those skills by continually educating ourselves and seeking the best references and resources available. And if we don't have the skills and we don't have the time to acquire the appropriate skills, certainly seeking out a professional in the area to do the work for us. A good reference is the Black & Decker Complete Guide to Wiring, updated 7th edition, current with the 2017 and 2020 National Electric Building Electric Codes. So with all of that as a precursor, most of us are familiar with these ground fault circuit interrupters. They'll be in our kitchens, in our bathrooms, in our laundry rooms and all, and probably far few of us actually do our testing and resetting of it, and we should be doing that once a month, just to make sure that this thing is functioning the way it's supposed to be functioning. So that's really important. So an arc fault circuit interrupter can look just like this as an outlet form. So there's really 3 different specialty receptacles that we can have. This is a ground fault circuit interrupter, which protects us from shock and electrocution. There's the arc fault circuit interrupter, which I'm going to talk about in a moment. There's also a tamper resistant receptacle to TRR. So this is a GFCI ground fault circuit interrupter. The arc fault circuit interrupter is an AFCI, and the tamper resistant receptacle is a TRRI. And with a tamper resistant receptacle, it helps to protect children and pets from electrocution by sticking a paper clip or a tweezer or a wire into one side of this and then becoming electrocuted. And how it works is that if there's a single item being put through one of these blades, so here's an outlet plug, and there's 3 on this because this is a grounded one. But if only one of these starts to poke through, it will resist that blade from going into the receptacle. So if you've got small children, if you've got small children and you want to protect them from a possible electrocution from sticking something into one of these holes, a tamper-resistant receptacle is the type to be put in. And they have other plugs that you can put into these as well that are just little plastic plugs that are non-conductive that can work as well. But I just wanted to mention there's basically 3 types of outlets that you could have. The ground fault circuit, the standard 4, with a standard outlet that you see in all homes and all. And then you have the ground fault circuit interrupter, which is this one, an arc fault circuit interrupter, which looks just like this one, but does a totally different, has a totally different function. And then we have the tamper-resistant receptacle. I know that's an awful lot in a short period of time. So we know what the ground fault circuit interrupter does. It's a way of protecting us from getting electrocuted when our hands are wet, or there's been a dripping from the sink and it's made contact with something that we're touching, and we're touching a wire that may be frayed some as well. A ground fault circuit interrupter is unlikely to prevent fires. As I mentioned in the facts and statistics at the very beginning of this video, is that it's arc faults that are responsible for so many house fires and loss of homes and you know, millions, $700 million in property loss each year. So by installing arc fault circuit interrupters, we can drastically reduce the likelihood that we're going to have an arc fault cause of a fire in the house. So by installing an arc fault circuit interrupter in our homes and in our workplaces, wherever we're in a building with electrical wiring, then we can reduce the chances of there being a fire and potentially save our lives and save ourselves from property damage as well. So there's 2 categories of arc faults. First, so what is an arc fault? When I think about an arc, I think about arc welding. That's the way I learned to weld years ago. And often referred to as stick welding. So you have a 50 amp or greater electrical circuit going to a machine, a welding machine, that has a ground wire that's hooked to a plate and then a handle that holds an electrode, and when that electrode comes in contact with that plate, it melts the metal to the point where, as the heat is reduced, as you move the stick along, the melted metals cool and create a weld. And it's responsible for so many of the things around us all the time, that the importance of the welding. Well, the important thing is that there's so much heat generated that it actually melts steel. And so there is the series type of arc fault is where, all right, so here I have this electric cord that has a plug. This happens to be a grounded cord, so there's 3 wires, like there's 3 parts of the prong. If you only see the two blades coming out of the plug, then it's a non-grounded plug. So there'll only be 2 wires as opposed to the 3 that are here. This one happens to have 2 white wires and 1 green wire. But a series arc fault is where there's a break in 1 wire and there's an arc. The electrons are jumping across that break and continuing along in that conductor, along that line. So that can generate some heat, but that's called a series type arc fault, where there's damage to one wire, one conductor, the line wire, and it's jumping across it. Of course, if the wire gets separated far enough, then the electrons aren't going to be able to make that jump as well. So this can melt cords and cause damage and lead to a parallel arc fault ultimately. But a parallel arc fault is when the line, there's damage in the line, and there's a damage to either the ground or the other conductor, and the arc is arcing across from wire to wire. So it's creating a bridge, a shortcut going from wire to wire, and that generates tremendous heat. And there are many different ways that this can happen. So it could be in some remodeling things in your home. So here's a piece of Romex wire. A nail or a drywall screw could be driven through this. I did this once years ago when I was putting up molding around a door, and one of the wires was right next to the, I drove a finish nail right into that, and it only created a series fault, which I didn't detect, but when I went to do the remodeling, I could see the damage there. Wires could get pinched if someone, so let's say, changes out a ceiling fan and a wire gets pinched in the ceiling fan. An extension cord or an appliance cord is run through a window or run under a door, and the door keeps abrading it and bending it. If the wire is next to a radiator or another heat source, and the insulation gets frayed and damaged over time. A furniture is repeatedly pushed up against the plug that's going into an outlet and all. A small pet chews on the wires in the house as well. I don't know, the possibilities are just tremendous. Being exposed to direct UV light, over time the insulation can get damaged, can become brittle and break down, and as a result there being arc faults across. So what can we do other than going around and checking all of these things all the time? It can be overwhelming. So by putting it in arc fault circuit interrupters, and if you're a do-it-yourselfer, you may just pick up arc fault circuit interrupters, and I'll put a link in the descriptions below to a couple of Amazon affiliate links for the types of breakers that I'm going to be talking about, and for some of the types of receptacles, both the ground fault circuit interrupters, the arc fault circuit interrupters, and the dual fault circuit interrupters. So if you feel very comfortable and handy, and I'm not suggesting that anyone do this to protect myself here, but one could go ahead and replace an outlet in a bathroom. And for example, this is a ground fault circuit interrupter, brand new one, so it comes with a yellow tape over the load side. So you really need to know these things. That's why you need to pick up a reference book or really know what you're talking about. So this is the line side. So when we're talking about the line going into an outlet, we're talking about the power coming from the panel. So if there's only one outlet in a room and you're putting in a ground fault circuit interrupter, you don't even have to take off this yellow tape, because this yellow tape would be removed if there's more outlets downstream that want to be protected with, in this case, a ground fault circuit interrupter. So it would protect electrocution from another outlet in the same room that's exposed to water. Hopefully that makes sense. So I talked about the two different types of series and parallel types of arc faults. So this is a standard breaker, and this is a type that came with one of the panels that I recently purchased. And this one probably won't get installed into the service panel or the sub panels. What will get installed are either arc fault circuit interrupters or dual fault circuit interrupters. Now this is an arc fault circuit interrupter, and this happens to be a combination. Both of these are combination arc fault circuit interrupters. So by a combination arc fault circuit interrupter, which is the type that you'd want to get, is one that's going to protect against both series and parallel types of arc fault. So these will trip. So typically there's a little light on it. So when you first charge it up and you trip the breaker on, that light will flash a few times, and each manufacturer is a little bit different and they're specific. So this is a GE combination arc fault circuit interrupter. And a GE panel may not fit in all panels. You need to get the appropriate breaker for each panel, each type of manufacturer. So I've got GE boxes here, so I got GE breakers. So it has a light that indicates when it first fires up, when you first charge the circuit, it will go through a test. And not the test where you press the button like you would the other systems, but there's a little system here that signals to it that there's an arc fault and it should trip the breaker. So how does that happen? Well, this is so much more advanced than like a ground fault circuit interrupter or your old-fashioned standard breakers. It actually has a microprocessor or printed circuit board inside of this that's constantly looking at the sine waves of both the current and the voltage. And when there's an arc fault, there's a disruption in the waveform of the current and the voltage going through the system. And when this detects that, it's going to trip the breaker. So then you've got to go through the process of saying, okay, what does this breaker go to? And you say, oh, this goes to the master bedroom. Well, which outlet's the first outlet in the outlets in there, or does it go to the lights as well? Does it go into the bathroom? It's really important, and I'll go make another video about mapping out our outlets and the electrical things in the order that they're in, and how I go about it as I'm doing all the remodeling around here. So, but I think that's really important, because you can't necessarily rely on, in an older home, opening up the panel and saying, oh, 1, 3, 5, okay, so this is number 7, this is a master bedroom. Well, if you look at those, sometimes you'll see different penmanship, different colors, different labeling throughout the process, because things changed over time. People made some changes in their systems and they added new breakers as well. So knowing where they go. So once you've got an arc fault detected, you need to go through and determine what's causing that. And it might be looking under, it might be the type of recliner that's a scissor type and there's a cord going underneath it and it's getting pinched in between. And so just go through those circuits or call in an electrician so that they can do that as well. But the more that you know about your electrical system and how it's all wired, the better off altogether. So these arc fault circuit interrupters detect and override other types of arc faults. So in an electric switch, this is an outlet, but let's say we've got an electric switch with a little toggle here. Every time that electrical switch is turned, it makes a contact and there's a tiny little arc there. Well, that gets fed back. The breaker or the receptacle that's the arc fault circuit interrupter is going to detect that. But these microprocessors or printed circuit boards are so much better at determining, well, this waveform is an acceptable form because it's likely an electric light. Or there's differences as far as, and we'll see what I run into in the workshop, with different motors starting up, and there's brushless motors and there's motors with brushes and there's little arcs that happen as a result of that. So I'll be experimenting to see how good these are in a workshop environment. I want as much protection for all the time and energy I put into, besides the money, but into building these structures that we build here, that I really want to reduce the chances of there being a fire, and electrical fires are a significant cause of fires. So this is an arc fault circuit interrupter. It is a combination, meaning it protects against both series and parallel. The newer ones are very good at overlooking normal occurring ones, such as your light switches. There's another type of arc fault circuit, what's called a dual function arc arc fault and ground fault circuit interrupter. So this does both things. I haven't popped this one out of the container yet. It has lights for that as well, but this is going to protect all of the outlets feeding downstream from electrocution as well as an arc fault as well. So they're very good. I hope that this video is making sense. My goal here is to inform you and give you some inspiration, encourage you to think about, geez, you know, what can we do to make this our workplace safer? What can we do to make our home space safer, and things to think about. And there's so many things that you can do, like remodeling. I don't know that you need to have an electrician. I'm not saying that you should do this, to install a ground fault circuit interrupting receptacle or a arc fault circuit interrupting receptacle. As long as you really take the time to really learn about this system and you feel comfortable and confident. If you don't, you need to contact an electrician to make sure that they do these things for you. And certainly in certain locations, you're not allowed to do it as well. And I wouldn't encourage you to break the law. So again, there's arc fault circuit interrupters. They protect against fires. Ground fault circuit interrupters protect against electrocution. Tamper resistant receptacles help to prevent small children or animals from putting something into an outlet and getting electrocuted as well. I think I've talked about all the things that I wanted to talk about. I'll put links to all of these things down below. Feel free to leave a comment, ask questions. I'm not an electrician. I'm not an engineer. I'm a simple guy trying to make the best out of life and make it as safe as possible and share what I know. So I hope this has been helpful to you. If you found this of value, please give us a thumbs up, share it with your friends, and by all means, folks, have a super fantastic day. Bye-bye now.